Okay, so here this one, the last class for this chapter, okay, on motion, class 9. So question 34 to 39, open your tuition note to page 101 up to 102. So let's go to 101 page, take out your tuition note. There, let me write the question for us. Question number 34, sorry. Write 3 ways by which velocity can be changed. Write 3 ways, or you can also say 3 methods by which velocity can be changed. In other words, we know that change in velocity means, it also means acceleration can be achieved. This is the question that we are going to discuss first. So when velocity changes, then we call that as acceleration. Means acceleration is equal to change in velocity. So how can you change velocity, or 3 ways by which we can change velocity or achieve acceleration? So let me read that. Velocity can be changed or acceleration can be achieved when A, magnitude of velocity remains same but direction is changed. So A, magnitude of velocity same but direction changed. So we can achieve it by changing the direction. Let me give you a classic example of how this can be achieved. Now if you take let us say the second hand of a clock, like on the wall clock, right? Now it is always moving with the same magnitude, meaning this velocity is magnitude or the speed is same. But that tip of the minute hand here that is rotating is always changing direction. So the speed is not changing, but the direction is changing. So we know that when direction change or magnitude change or both change, that is called acceleration. Acceleration means change in direction of motion, or change in magnitude only, or change in both, or change only in, change only magnitude, then also acceleration will change. Change only direction but don't change magnitude, also will change. Change both, right? So these are the 3 methods. But anyway, the first is keep the magnitude same and change direction. Example, the tip of the minute hand that is rotating, it is always changing direction even though the magnitude or speed is remaining same. Second method is, first is direction. Opposite to this, direction remains same, direction of motion remains, or direction of velocity remains same, but change the magnitude. Change the magnitude. So let us say an object is moving from east to west direction. So from here to here, 1 kilometer, it is moving with 40. It is moving, let us say, with a velocity of 40 kilometer per hour. Then this one, from here to here, another 1 kilometer, same distance, it is moving with 50 kilometer per hour. So you can see that the magnitude is changing from velocity of 40, number is changing, means magnitude is changing, but the direction is remaining same, like it is still going towards the same westward direction. So here direction is, car is moving towards the west, same direction, but the magnitude is changing all the time, 40 to 50, then to 60 maybe, then to 80. So that is how we can change the velocity or achieve acceleration. Second method. First method, magnitude remains same but direction change, like the tip of a minute hand. Second method, direction remains same, like a car moving from east to west, but the velocity is increasing, like 40 to 50, magnitude is changing. Second is direction remains same but magnitude change. It can even decrease also, right? Now third method is, you can achieve it by both change both magnitude as well as direction. So this is the third method by which we can change the velocity or achieve acceleration. Example will be a car moving in a circular direction in a big field, let us say. So let us say this car is moving from here 0 to 1 kilometer with a speed of 40 kilometer per hour. Then the next 1 kilometer, that is 2 kilometer, it is moving with 50 kilometer per hour. And the next here, in the third kilometer, is moving with, let us say, come down to 30 kilometer per hour by applying brake. So the magnitude is changing all the time. See here, after each kilometer, 40 changed, increased to 50, decreased to 30. So magnitude is also changing and direction is also changing. Like that we can achieve. So the three ways by which velocity can be changed. In other words, acceleration can be achieved, because change in velocity is acceleration. No change in velocity is zero acceleration, meaning no acceleration. So change in velocity or acceleration can be achieved by keep the magnitude same and change the direction, or keep the direction same and change the magnitude, right? Or change both magnitude and direction. So these are the three methods by which we can achieve change in velocity or acceleration. Let us read through the note there given on your question note. Number A, magnitude of velocity remains same, first method, but direction of motion changes. Example, uniform circular motion of a object like the tip of a minute hand. Number B, direction of motion remains same, so the direction same, but magnitude of velocity changes. A car increasing its speed gradually along a straight line in same direction, but gradually increasing or decreasing also you can put if you want. Increasing is enough in a particular same direction, so their direction is same, but magnitude is changing all the time, increasing or decreasing, either way is possible. C is when you change both magnitude of the velocity as well as direction of the motion, then also acceleration or change in velocity can be achieved. Magnitude as well as direction. Example is a car gradually, so I told you a circular motion, but in real life also, in the hilly roads like KOHIMA and all, right, as the car goes through the curve, they're going through a high speed, and when it reach a curve, apply brake and slowly, gradually slow down, and then when it cross the curve again, increase the speed. So there, when it is going through the circular bend of the road, the speed is changing all the time and the direction also changing. So there, both direction of the car as well as the speed is changing, decreasing by application of brakes. So that is the example of both change in magnitude and direction. Go to the next question, 35. We'll just read through this. By now you're gone through the most of the chapter, so you will pick it up from there itself, I think. I'll read the question. Write the differences between uniform linear motion and uniform circular motion. Uniform linear, uniform circular. What is the difference? When an object moves in a straight path with uniform speed, like a car moving in a straight road with 40 km per hour all the time, that is called uniform linear motion. Linear means straight line motion. Next, right side. When an object moves in a circular path with uniform speed, it is called uniform circular motion, like the tip of a second hand of the clock. Always moving with the same speed but changing direction all the time. So circular, always in circular motion. Okay, so next, B. In uniform linear motion, number B, here the direction of motion does not change. So the car is moving with same uniform speed and in the same direction in a straight line. Here the direction does not change. But in the case of uniform circular motion, like the second hand of a clock, the speed is uniform but the direction is changing all the time. Next, point C. In uniform linear motion, motion is not accelerated because it is going with same speed, 40 km per hour, and in the same direction. So there is no acceleration. So it is not accelerated, means zero acceleration. But in the case of a uniform circular motion, like the tip of a second hand, even though it's all, we know that the second hand moves with uniform speed, it is always changing direction, and change in direction alone is also called change in velocity, right? So here motion is accelerated because there is change in direction. So there is change in velocity. Change of velocity can be achieved by changing direction alone also, even though there is no change in the velocity. So here motion is accelerated in uniform circular motion. Question 36. Write some examples of uniform circular motion in nature, means daily life. Number A. For example, the moon moves around the earth in uniform circular motion around the earth. The earth is there stationary, let us say, and the moon is moving around it in a circular, uniform circular example. Number B is motion of satellite around its planet. A satellite is moving around a planet in a uniform circular motion. Number C, motion of earth around the sun. Sun is stationary, the earth always revolves around the sun, we know that. But that is uniform but circular motion, right? An athlete running on a circular track with constant speed. So suppose a sports person, athlete, is running in a perfect circular track with the same speed, then that's called uniform circular motion. E, motion of the tip of a second hand or a minute hand or hour hand. All the three hands, hour, minute and second hand on a clock, wall clock, all of them move with circular motion, and their motion is always uniform, meaning uniform circular motion. Okay, I think that's quite easy. 37. Look into your tuition note, page 102. Uniform circular motion is not accelerated. Uniform linear motion is not accelerated because magnitude is also 40 km/h on a straight line. Magnitude is also not changing, direction also not changing, so it's not accelerated. Accelerated means change in magnitude or change in direction. None of those two happen in a uniform linear motion. Linear means straight line motion, so there is no acceleration. But uniform circular motion is always accelerated because it's always changing direction. Yes, okay. Now next, question number 38. Write the equation for velocity of a circular motion in one circumference. So let us say we have here one question number. Let me write down this one for us. You can scribble on your tuition copy. 38. It says, write the equation for velocity of a circular motion in one circumference. If athlete takes t seconds, let's say if athlete means a sports person, takes t seconds means time, t seconds to go once around, okay, to go once around a circular path, of radius r, then velocity v is given by, see here, this is the circular track, let us say. So we have to go from here to here, one round circumference means one round distance, take t seconds, then the velocity v will be given by this velocity will be given by this circumference. Distance here is 2 pi r, right, divided by velocity is displacement by time, right, 2 pi r by t. Okay, for velocity of, so divided by t, time taken, because formula for velocity is displacement by time or distance by time, right, displacement by time. So this is the answer. Question number 39. Let me read the question. With an example, show that the direction of motion change at every point for an object in circular motion. Let us just read through this. You will just get it like that. A stone tied to one end of a rope. That means you tie a piece of stone on a rope, and then what do we do? And you rotate it in circular motion on being released, and then you rotate like this and then release it. As soon as you release, the stone will begin to move in a straight line tangential to the circular path. This is because once the stone is released, it continues to move along the direction it has been moving at that instant. This showed that direction of motion change at every point for an object in a circular motion. Read the question again. With an example, show that the direction of motion change at every point for an object in circular motion. Direction is changing at every point. We know that by our own sense, but how do we prove it? You see here, tie the stone and rotate, and as you release the stone, here, see, rotate, and then as you release it, the stone will begin to go in the straight line, and if you extend this, it will touch this circular path at only one point, means that line is called tangent. So this proved that this is because when it is released, it would have changed direction, but then because it's released and it was going in this direction, it continued to move in that direction. This proves that at every point on this circular path of the rotated stone, there was change in direction. Okay, so that concludes our class for chapter 8 motion, class 9. Okay, no test for this. Okay.